Welcome, ladies and gents, to another lesson from via video. Today we're focused on negative exponents, which is kind of sort of lesson 5-2, but it's kind of building it up a bit. Now let's pause for a moment, take a look at your assignment number 5. Check your answers, please hit pause, come on back when you are ready. So focus today continues to be simplifying. We're not solving, we're simplifying algebraic expressions. But now we have to make sense of what a negative exponent means. After all, you know what a to the third means. It means a number a times itself repeatedly. Or what a to the second means. Or even what a to the first. Or we learned a while back that a number to the 0 power is 1. However, what would this mean? How do you multiply a number times itself negative times? That is nonsense. But what we're going to do is we're going to use our algebraic skills to turn it into something that makes sense. It is something that is real and tangible, and we'll be able to use that for things like scientific notation. If you look at the distance from the Earth to Saturn, or that's a huge number, something tiny like the diameter of one strand of hair. What do these numbers mean, and how can we represent them? Now, here's the kicker. Any non-zero number, and it's important that it's not 0, because after all, you cannot divide by 0. That's nonsense. Any non-zero number raised to the negative n power is the inverse of its nth power, meaning a to the negative n is the same as saying 1 over a to the nth power. Again, make sure that denominator, make sure that a value is not 0. As an example, 5 to the negative 4th, you could rewrite as 1 over 5 to the 4th. Or m to the negative 3rd, you could rewrite as 1 over m to the 3rd, the inverse of the 3rd power. But why? Where does that come from? Well, let me show you a couple things. Number one, I want to show you the backwards proof. Remember, please, that 1 is the same as saying 5 to the 0 power. But if you're dividing powers, you can subtract the exponents. And therefore, 0 take away 4 is negative 4. That's kind of strange. It kind of uses the backwards motion. So I wonder if we could do the forwards motion. Let me give you an example. 5 to the negative 4. You could rewrite that. I think we'd all agree that 1 take away 5 is negative 4. What we learned about powers the other day is that when you divide powers, you subtract the exponents. So we could rewrite 5 to the 1 minus 5 power as 5 to the first divided by 5 to the fifth. Now imagine writing that out. And as we mentioned the other day, any number divided by itself is 1, and look at what is left over. 1 over the inverse, 1 over 5 to the 4th power, the inverse of 5 to the 4th. Now, in case you're saying, well, Mr. Callan, what's up with the 1 minus 5? Could you do a different subtraction piece, and would it change it? Well, imagine 2 minus 6. I think we'd all agree 2 minus 6, still 5 to the negative 4. Rewrite that as the division of 2 powers as long as the base of both are 5. Now multiply or expand out these powers. 5 to the 2nd divided by 5 to the 6th. And look at what happens. 5 divided by 5 is 1. And another divided by 5 is another 1. And what do we end up with? Still have 1 in the numerator, still have 5 to the 4th power in the denominator. And you can imagine then that it really doesn't matter what you do with this subtraction equation. We could use 10 minus 12. We could use 99 minus 101, but who wants to write out that many 5s and cancel out that many 5s? So that's just a basic understanding of, okay, we take something that is nonsense. How do you multiply 5 times itself negative times? And we turn it into something that makes sense. 1 over 5 to the 4th power would be like 1 over 625, some small piece like that. So that's the y. Let's keep doing some practice problems. Write each expression using a positive exponent. In other words, let's take something that's nonsense and turning it into something that makes sense. So first we're going to write the inverse of 6 to the second power. Or x to the negative 5. The inverse of that would be 1 over x to the positive 5. 5 to the negative 6. 1 over 5 to the positive 6. And t to the negative 4th. 1 over t to the positive 4th. Well, again, at any time, we could make up some random problem, 4 take away 9, turn it into a division of 2 powers, ask ourselves what any number divided by itself is. 1 times 1 times 1 is 1, and x to the 5th power remains. Just taking something that is nonsense and turning it into something that makes sense. Now let's go the backwards direction. Act like you're the teacher. You have an answer, but you want to write a problem to it. So how could we rewrite these expressions with a negative exponent other than negative 1? Well, we're going to write d, and then what number would we fill in here? Well, instead of 5, we're going to write negative 5. Again, we're used to going this way. Now I'm just asking you to go backwards and act like you're the teacher that you want to write the problem. Now, you might be tempted here to write 9 to the negative 1. But they said in the directions, we want something other than a negative 1 exponent. So it's not that that's wrong, it's just not exactly what we want. So I'm going to write that off to the side. I wonder what I can change 9 into to make it in a power form. Oh, well, how about 3 to the second power? 3 times itself, 3 times 3 is 9. So now we can rewrite this with what negative exponent? We can rewrite negative 2. So again, it's not that 9 to the negative 1 is not accurate. Those are all the same quantities, but they're asking us to rewrite it with a negative exponent other than 1. So sometimes you might have to finagle with the number to help you out with problems like that. Now, we get into the big fellas. Actually, if you want, pause and go ahead and start some homework up and then come back to it. We'll go ahead and start this. Simplify x to the third multiplied by x to the negative 5th. Now, the first thing I'm going to notice is that the negative 5th, that is nonsense. So I would like to rewrite that as something that makes sense. Now, from here, if I slip a little 1 underneath this x to the negative 3, I now find that we have 1 times x times x times x. X to the third power remains in the numerator. Down in the denominator, we have 1 times x times x. Well, x is multiplied repeatedly 5 times. And now I'm basically going to ask myself, is this a combine or a cancel problem? Well, in this case, any number divided by itself, 1. Any number divided by itself, 1. Any number divided by itself, 1. So we are left with 1 in the numerator and x to the second in the denominator. And that is our final answer. We took a 2-term expression, we simplified it to 1 term, and we got rid of the nonsense negative exponent. Now, I will show you the faster way using what we have already learned. Remember, please, we have learned that when multiplying powers, we can simply add the exponents. Now, positive 3 and negative 5 put together are 0 pairs. That leaves negative 2. Wait a second, that is nonsense. Let's rewrite it as something that makes sense. Now, I'm going to be honest on the homework. I was not specific with the directions. I got this worksheet from another teacher. It doesn't say simplify, but make sure you write it with a positive exponent. I don't know why you would leave anything with a negative exponent, because negative exponents are nonsense. There is one reason to do that. That's scientific notation. That's going to be coming up in the next couple of days. Now let's go ahead and simplify a division expression, where in this case we have x to the negative fifth divided by x to the negative second. Now buckle up your seatbelts. I'm going to give you the bumpy ride first. Remember, please, that negative 5 is a nonsense. So let's take the inverse of that and turn it into something that makes sense. We also note that x to the negative second is nonsense. So take the inverse of that. All right, you know what, Mr. Cowan, this is fractions inside of fractions. You'll do that a little more in high school, but why don't we just go old school with this and write division like this? 1 over x to the fifth divided by 1 over x to the second. Whoa, hold on. There is no division in the dividing fractions. We multiply by the reciprocal. Now again, I told you, this is the bumpy way. But now we can expand out x to the second divided by x to the fifth. In this case, we end up with 1 in the numerator. It's not always going to be 1 in the numerator, but in this case, it is x to the third in the denominator. Some of you are like, come on, Mr. Cowan, wait a second. Didn't we learn something about dividing powers before? And the answer is yes. Remember, please, when you divide powers of the same base, you may simply take their exponents and subtract. Now, you know, Mr. Cowan, I like change the subtract to add the opposite. After all, when you take away negative, it increases. When you take away -2, it goes up. So in this case, we end up with -5 plus 2, still in the negatives. Wait a second, that is nonsense. Let's write it as its inverse and turn it into something that makes sense. I'm showing you guys one of the most, I think, challenging number sense issues in pre-algebra before next year. Pause if you need, rewind and rewatch that video if you want, decide which method, but I will warn those of you that remember shortcuts, that's great, as long as you can remember it not just for 1 week and not just for 1 month, but for 1 year. If you cannot do that, then you need to go old school with method 1. Change the negative exponents into something that makes sense, and decide in the end if this is a combine or a cancel problem. We end up with x's divided by x's, which cancel out. Frankly, the best students, the students with the strongest number sense, I should say, should be able to do it both ways. So that is a challenge for some of you that need that challenge. What happens if there are both coefficients and powers? Well, you know, we already learned, according to the commutative property, that we can change the order and change the grouping, the association, and still have the same answer. So in this case, how can we simplify 8 times 2? Mr. Cowan, come on, just multiply them. And then what do we know about m to the 6th times m to the negative second? When you're multiplying powers, you can add their exponents. The only reason I put that parentheses is so that you don't have plus and negative, but some of you just write plus and negative. In this case, we end up with 16m to the 4th power. All right, what about division? Well, I would venture to say, why don't we just rewrite it as 8 divided by 2 and m to the 6th divided by m to the 2nd? Excuse me, that's a negative second. That's going to be important in a moment. 8 divided by 2, not a big deal, but remember what happens when we divide powers? We simply take the 2 exponents and we subtract them. All right, I really want to put that parenthesis. Okay, I'm going to do it. Sorry, I got stuff. Who wants 2 negative symbols right next to each other? Speaking of, subtract negative is the same as adding the opposite. So we end up with 4m to the 8th power. Now, for those of you that went old school there, we have m to the 6th divided by 1 over m to the 2nd. And anytime you're dividing a fraction, you multiply by the reciprocal. The reciprocal of that would be, oh ho ho, that's why everything ends up at the top. M to the 6th times m to the 2nd. This is not a cancel problem, this is a combined problem. That kind of explains why we end up adding those. Let's do one more, and let's make it one of the word problems. So the back side of your homework. If you want to, pause, do a few more homework problems, and then come back when you're ready. But I think this will wrap us up for today. Virus average length is tiny, 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 10 to the negative 7th meters. I shouldn't say meters plural. This is actually a tiny part. Think about what that means. The inverse of the 7th power. So we're talking 1/10,000,000th. 10 times 10 repeatedly. So that's a tiny, tiny part of a meter. An atom, if you thought that was small, check out an atom. So the question says how many times, and you know what? I'm kind of disappointed in this worksheet. It should say how many times greater, maybe just a little typo, but nevertheless, that's kind of important. How many times greater is a virus compared to an atom? Okay, so let's act like we have a hugely powerful microscope. And so you go across a virus and you find the virus to be this big. But the truth is, an atom is much smaller. So the question is, how many atoms will fit inside? And that's the important part to understand, because when you're talking about fitting inside, you realize this is a division problem. We have a 10 to the 7th, 10 to the negative 7th exponent. And we are going to divide that, as small as it seems, it's not even close to as small as this fellow. All right, I think that's the toughest part of the problem. From here, we know that when we divide powers, we can simply subtract the exponents. And yes, when you subtract a negative, it does increase. And then we end up with 10 to the 3rd power bigger, greater. If you want to write all that out, 10 times 10 times another 10. In other words, I should have written times greater. As tiny as a virus is, it's 1,000 times greater than the average length of an atom. So with that in mind, folks, again, you should have the assignment number 6. If it's not written up there, please write assignment number 6. So you make sure to put that in your binder in proper order. Front side and back side, but I just did number 3 on the back side to help you out. That was a long video. It's kind of a tough assignment, but good thing we got a couple days for it. This is due by the end of Thursday. And then Friday, we will have one more assignment, I believe, on exponents. I think that's finally getting into more scientific notation. If you have any questions, let me know. Don't forget to study for your test, and have a nice day.